This is Jason DeVoe, Application Technology Specialist with OMAFRA. This talk is Crop-Adapted Spraying. It's a 3-year study in highbush blueberry. In 2016, pressure from SWD prompted a 15-acre highbush blueberry operation in southern Ontario to make significant changes to their crop management practices and their spray program. They called us a few times, a little frustrated with how many products they had to use and how frequently they had to use them. And as I recall, the original question was, can you come out here and research new pesticides for us? Of course, the answer to that was no, but maybe we can come out and help you use the pesticides that are currently registered a little more efficiently. And they were open to that. The beauty of working with a cooperator that's fairly new to the operation, as this operator was, is that they're very open-minded. We decided on a three-pronged approach to improve crop protection. So first, and the grower had already decided to do this, they made significant changes to canopy management and picking and culling practices. Second, we decided, and this is only the second time in my career I've ever advised this, that the sprayer just had to go. We had to invest in a new sprayer. And finally, we adopted the crop-adapted spraying, or CAS, method of dose expression, and I'll explain all these. The idea was that over a 3-year period, we would track total pesticide use, water use, hours spent spraying, and explore the yield compared to what the operation had managed historically. Also, we tied into an existing study looking at spotted wing Drosophila catches in crop. We also looked in wild hosts surrounding the operation along the border and in other southern Ontario farms. So that was the 3-year study. We'll start with canopy management. As I mentioned, the grower had already decided, after having purchased this operation, a 30-year operation, that the overgrown bushes were in for a good haircut. So there was a heavy pruning in 2016 to get them down to a manageable size. And of course, there were real concerns. Oh no, you take out all this bush, you're cutting away all of our production. And just as an aside, no, that wasn't the case. These berries produced the same volume and perhaps even a better quality of fruit, having gotten a good haircut, as they would have with all these old canes in place, or bush branches, I guess. So after their heavy pruning, they were pruned each year about 30%. And that maintained an ideal shape, an ideal size, gave good airflow, good light penetration. And this is an image of a early season, what those bushes looked like. The pickers were educated. It was explained how to pick cleanly so there was less damaged fruit left on the bush, and fruit that fell to the ground either from mechanical disturbance or just discarded culled fruit was then collected and buried regularly. And they had this backhoe at the other side of the operation where they would regularly bury the fruit. Now, onto the sprayer itself. In the foreground, this beast, this 25-year-old sprayer, is a 1,000-liter Kinkelder. And this is a twin fluid system. So those two weird shoes at the back are air shear systems, where air itself is used to break liquid up into tiny droplets. And the air energy required to do that is ginormous. This sprayer was originally built to spray standard apples in the 70s and 80s. And now it's being used in highbush blueberry, literally half a meter away, and only about a meter wide for the canopy width. So just overpowered and not appropriate for this crop morphology or the planting architecture. But beyond that, it had seen its day. It was leaking, and it wouldn't shut off properly or promptly at the end of rows. So there was a lot of product that just simply poured out of it when we didn't want it to. It was just beyond its prime, quite obviously. So the operator decided to purchase a 1,500-liter turbo mist. And honestly, it could have been any sprayer. They went with a low-profile axial, like the one in the background here. It's a bit big, for my liking, but good salespeople said, get the big one, less fills. But to my mind, this larger sprayer was still too much for this operation. It still had the potential to brush against the fruit as it went down through the alleys, although it didn't. It did have that potential. And this turbine system, it just produced way too much air. So we ended up having to cut back on the air energy it used, but we'll get into that. The new sprayer was more reliable. It didn't leak. It shut off when it was required to do so, and it was far more fuel efficient. And I did mention the old sprayer leaked and didn't respond. And I also mentioned that they perhaps went with a larger sprayer than I might have recommended. So crop-adapted spraying, this is not complicated. Crop-adapted spraying is just a protocol or a method that formalizes what a lot of growers do already. And at its heart, it's simply matching the sprayer's configuration to the size and shape and density of the crop you're trying to spray. Consider, you would never use a sprayer set up for an orange tree to spray a raspberry cane. They just don't fit. So growers know that, of course, and they make changes to adapt the sprayer to the crop. But what changes do you make? How do you diagnose those changes? And that's what crop-adapted spraying is. And pictorially, this is what it would look like. Before any kind of calibration or optimization, you can call it what you want. This is typical of what you see for a sprayer and a crop interaction. The red is excessive air energy, which means it's going to blow spray over, under, or through the target, which is a waste. We don't want that, unless, of course, you are trying to spray multi-rows, but that's a different talk. For our purposes, we're trying to spray the immediate row adjacent to the sprayer. And you can see that's a lot of wasted energy, a lot of wasted product. You also get gaps, non-uniform coverage. Some places don't get any spray, some places get too much. So there's no way for an operator to see any of this from the cab. They can't see what's blowing through the plants, at least not easily. They may or may not be able to see what's blowing over or under, and they certainly can't discern changes in coverage. In fact, we've tested it. An operator from the cab can't detect one nozzle putting out twice as much volume or flow from its neighbor. You just visually, you can't discern it. So this protocol takes that dog's breakfast and cleans it up. Anything that's blowing over or under or through the target isn't needed, so we back it off. Any gaps, we add spray into that. We change the distribution. Any oversprayed portions, well, we steal from Peter to give to Paul. Now, of course, we need tools to do that. If we're going to formalize this approach, we do need some black and white yes and no situations. So the first thing we do is adjust the sprayer's air energy. That is how hard it's blowing, how much volume it's blowing. And we do that simply with ribbons. It's a really easy trick. It's been around a long time. 10-inch or 25-centimeter ribbons are tied on the far side of the upwind adjacent target. Lots of big words, but the picture will handle it. And we drive by, blowing, just blowing. And an observer standing in the next alley, wearing goggles, I should hope, watches the ribbons. If they stand straight out, then you're blowing too hard. There's simply too much air coming out of the sprayer. It's blowing straight through the target, and you're going to end up with a lot of waste. You're also going to change the way that spray covers the plant, but again, that's another talk. So we don't want to see that. We also technically don't want to see the ribbons not move at all. Now, in a larger canopy, that's not such a problem. That might mean that the spray and the air, I should say, is penetrating beyond halfway and just doesn't escape the canopy, and that's okay. But in highbush blueberries, such as what we're talking about here, we don't want to see those ribbons limp. We do want to see some slight movement. Frankly, anywhere between 0 and 30 degrees would be great. But I would much rather see a slight ruffle of one of these ribbons than I would see it straining and standing straight out. So that's how we set up the air. Now we have to consider travel speed. And it's interesting and maybe surprising to some growers. They tie travel speed to productivity. The faster I drive, the faster I get the job done, the better it is for everyone. Well, not really. Travel speed is a tool. It should be used to control how long a target spends in the air wash. Another way to think of it is dwell time. The longer a sprayer is aimed at a target, the more effectively it's going to push empty air, we'll call it, or displace it with spray-laden air. That is the air produced by the sprayer full of droplets. And that's what this image is showing. If your objective is to replace all the air in the target, then the way those ribbons move and how fast you drive are tied together. If you're driving too slow or blowing too hard, you get the middle picture. You tend to blow things right out the backside, and we don't want that. If you get it more like what's above or at the very bottom of the image, as long as you're driving every single row, then that's ideal. So the way the ribbons move is how much air you're using, where that air is aimed, and how fast you're driving. And once we get them moving the way we like, then air is done. The next consideration is coverage. And it's pretty subjective to look at a plant and say, yep, it's dripping, that's good. Or I can see shine on the leaves, or there's residue there. That's all better than nothing, but we'd like something a little more quantitative. And while this method does have its limitations, it really is fast, easy, and effective. It's water-sensitive paper. You can buy them in packs of 50. And this looks a little like close-up magic, but it's really a step-by-step on how you can prepare papers ahead of time for this evaluation. You take 11 out of the packet, you flip one over because the yellow side is sensitive to water and will change blue when it gets wet. We don't want to handle that side, so we just flip one over, and that allows us to pinch the remaining 10, fold them over on themselves. And now, cheaply and effectively, we have two-sided paper. It'll respond to both sides. We flex that little packet and drive a pin through one corner, drop them in a Ziploc bag, and they'll keep that way quite happily for a few weeks as long as they don't have any moisture, and they can be pinned up throughout the plant. Then we spray and we look to see how we did. Interpreting coverage is tricky. We won't go too far into that here, except to say research, experience, and this comes from all over the world with conventional products, not organic products or those that don't offer control. Generally, we get good responses at 85 drops per square centimeter and 10 to 15% of the surface covered. And it's not written here, but you want at least 80% of the papers that you put up to look this way. If you get more, well, it's going to be efficacious as long as your timing was good. So that's okay, but it's a bit wasteful, and sometimes it can't be helped. But if you get less on more than 20% of the papers, then it might lead to control problems. So this is just sort of a sliding scale of different kinds of coverage. Now, what about rates? I think we have to change how we think about rates. Our labels are written in a per planted area fashion. For example, spray 100 grams of product per hectare of planted area. There are orders of magnitude differences in how many leaves there are in a foliar application to cover on a hectare. And this illustration looks a little convoluted, but bear with me. The large orchard on the left has so many leaves per hectare. If we were to pluck every leaf off the tree and lay them out like a quilt, we'd see so much surface area that needed coverage. And let's say that we achieve sufficient coverage using 1,000 liters per hectare or 100 gallons an acre and so much product. So we fill our tank, we spray, we get the coverage we see on the left. Now, a smaller orchard, say a medium-sized orchard, let's say we can get exactly that same coverage using half the spray mix, only 500 liters per hectare. Or for a small orchard on the right, maybe we can get that kind of coverage only spraying 250 liters per hectare. The point to this is, if we put the same amount of product in the tank for all three situations, then we have the same concentration. If we can achieve the same coverage on the leaves, then it doesn't really matter how much spray we put out per hectare. The tree knows no difference. It has the same coverage at the same concentration, so effectively has received the same dose, all three situations. So can we do that? Yes, we can. The rule is that we never exceed the amount of product per hectare, and for very good reason. Maximum residue limits, environmental safety, all that good stuff. We absolutely can never exceed a label rate. But within reason, if we're sensible and we use coverage indicators like water-sensitive paper, and we maintain our concentration, there may be room to go and use less. And that's I don't want people to think crop adapted spraying is a way to cut rates. That's really not right. What it is a way to maintain uniform coverage, no matter the crop architecture, that minimum threshold coverage, and reduce the waste. And this isn't new. People do this already. If you're changing from one crop to another and it's maybe a younger crop, maybe you speed up a little bit, or maybe you turn off the top nozzle because there's nothing there for it to spray. Well, that's a pro rata change to how much product you're using. You've made a cut, but it's a very sensible cut. And that's what crop adapted spraying really is. And we make those changes not only at the beginning of the season, but throughout the season. In this example with hops, as the plant grows up to 16, 20 feet high, obviously we have to make changes to the sprayer settings to reflect that. And you can see 4 growth stages here, and what we would loosely recommend for a low profile Airblast sprayer. Not only how much air is used over the bine, but concomitantly how much water and how much product is required will also change. So it's really a very sensible way to approach it. And we did the same with blueberries. Mid-season, we went back and checked, and at the end of the season, of course, we went back and checked to make sure that when conditions changed, the sprayer settings reflected that. So what does all this mean? What are the results of all this? Well, the new sprayer, just swapping sprayers, was far more efficient. We estimated about 10 or 15% was saved just by being able to turn off the outside boom more quickly and more effectively when turning on rows. And there was no dripping. This system didn't have check valves, so it just kind of poured out when the side was turned off. And that all stopped. So faster response and a more effective sprayer in itself was a worthy thing to do. But when we did the math, because we were using less product and less water, and I'll get to that, we figure we saved about 15 hours of saddle time a year in refills. We didn't need quite so much water and product, and that meant a lot less time actually spraying. And that was a bit of a surprise. This is only a 15 or 16 acre operation, and I didn't expect that kind of cut in time, but the math bore it out. So let's look at the product cost. This is just what the grower chose to use on his crop when he chose to apply it. All we changed was how much was actually sprayed. And in 2017, before we started this little exercise, he was spending about $7,500, $7,600 in product. In 2018, 2019, and 2020, the 3 years of the study, he ended up with a total savings of about $15,000. That's 65% of his annual pesticide. And honestly, that is far more than I had ever tried before. I think we've gotten as far as 40 or 50% savings in orchards. And there are a lot of reported cases where this system was applied in nurseries where they could manage maybe 40%. But that original sprayer was just, there was so much overspray. There was a lot more room for savings than maybe in a typical operation. So 15,000 in 3 years is pretty awesome. In fact, we estimate that in the 4th year, that new sprayer, the return on investment, it'll have paid for itself just in pesticide savings. We can look at volumes. That's a different way to look at it. We used a lot less water, again, about 62.5% savings in water. So if an operation has difficulties during time of drought, getting enough water to make ends meet, and it depends really where you are, this may be an appealing approach for them. Now, this is tricky, and I'm sorry about this graph, and I hate to be the guy that says I'm sorry about the graph. Why did you show the graph? I'll just walk you through it. In 2016, these are harvest weeks, week 1 through 9. And these are how many 9-pound flats were packaged each week. Now, 2016 was before there was a new sprayer. It was before crop adapted spraying. And you can see this sort of bell-like curve where from week 1 to week 9, you can see that 12,076 flats of berries were picked. In 2017, when they got the new sprayer and pruned all the crop, we went up. We went up by about 6,000 flats. That's impressive, given that the only change at that point was a new sprayer and a heavily pruned berry patch. In 2018, this is where we adjusted the rates using crop-adapted spraying. And what did we end up with? The same number of flats, and reports that harvest quality had gone up. There was less culling on the line reported by the grower, which saved a lot of time and effort. So no impact at all on the amount of fruit harvested. Now in 2019, we had a little confound. It had nothing to do with the study, but prices really fell flat at the end of the season. So in week 7 and week 8 and week 9, they more or less just decided it wasn't worth picking. So that kind of flattened out our flats. But up to that point, we were on course for the 18,000 flats. No difference. And in 2020, well, we all know what happened in 2020. What a dog's breakfast. There were possible labor shortages. They weren't really sure what was going to happen or how many people they could get to pick. So they heavily pruned the crop more than even before, assuming they would have a reduced year. And again, 14,000 flats. And if you kind of line the curves up, a later picking season and an earlier ending to the season, it still was online for 18,000. The point of this is reducing the amount of product applied, or applying it more accurately, I should say, had no impact on yield or yield quality. And in fact, culling the bushes, cleaning up the pruning may have increased the amount of fruit and the cleanliness of that fruit. Now on to the bugs. Harvest is great, and most people might want to stop there, but we also used spotted wing Drosophila as an indicator of how much control we were getting. The grower also reported disease control was more than adequate. So this is the counts from our traps from June through to August. And in 2018, we found 92 more spotted wing Drosophila captured in the grower's standard practice, or I should say in surrounding areas that used a standard pesticide method versus what the grower was doing. Is that significant? Probably not. We shouldn't think that more spotted wing Drosophila means more damage. I don't believe there's a correlation. If you find spotted wing, you're going to have damage. But if you find twice as much spotted wing, I don't think that necessarily equates to twice as much damage. It's enough to say that you have it and that you should be spraying for it. Now, in 2019, we found more spotted wing in the crop-adapted spraying, what the grower was doing. And in 2020, it was about par. But when you add all this up, week for week, there was almost no difference whatsoever in the spotted wing found in the grower's operation versus what neighboring operations were doing with more conventional pesticide application. So that leads us to say he was getting as good a control as anyone else, no matter how much product he was using. So can you do this? Of course you can do this. Yes, you can do this. It really isn't all that difficult. It's just formalizing these intuitive things that we do already. First, you have to remember that crop management is an absolute must. You cannot adjust sprayer settings unless they match the size, shape, and density of the canopy. And I think we all understand that. But that goes beyond just adjusting nozzles and how fast you're driving. You've got to prune that bush. You've got to let air and light in there. If you do that, you'll also let spray in there. It's just good IPM, which I just said. Culling fruit, burying them, bagging them, getting rid of them, getting them out of the blueberry patch, at least for spotted wing Drosophila. Very important. We know that. It's just part of good pest management. What you may not realize is detailed records. If you're going to make a bold change like this, and I recommend that if you're going to try this, that you only do it in a few rows or maybe one part of the operation and use it as a check. Watch it very carefully until you're comfortable with it. And that means keeping really good records. What was the weather like? How much product did you use? Anything you might notice. Conversations about buffer zones are outside this presentation, but if you want to be able to look back and figure out, wow, that was great. How do I do that again? Or, oh, that was terrible. What do I do to prevent that from happening again? Only application records can provide you that information. And use diagnostic tools. Don't guess. This image just shows this simple diagram that we drew of where the papers were placed, some of the environmental conditions at the time. There's the water sensitive papers. Take pictures of them with your cell phone and email them to yourself. Now they're timestamped. You have a quick and easy way to check back on coverage so that if you like what you see or you don't, you can look back and see what your spray quality was like or your coverage was like at the time. And check periodically. When the wind picks up or suddenly it gets bone dry outside, your spray coverage is going to change. If your crop is much denser and has doubled in size, well, you're going to have to make a change to reflect that. So be prepared to go in and take an active role, and don't be afraid to make changes to your spray program to reflect changes in the crop. And that requires you to take an active role. It's not just spray and pray anymore. If you want to have these efficiencies, if you want to improve productivity, then you have to constantly, well, not constantly, but regularly monitor the coverage that you're getting. And as I said, start slow, maybe a few rows, maybe one patch. Convince yourself that it works, ask questions, and then when you're ready, you can expand it, roll out to a larger part of your operation. Uh, Blatant plugs, if you want to learn more about this process, if you want to learn more about how to use air-assisted spraying in any number of crops, I'm very happy that my colleagues and I have been working for the last 14 months, I guess, at the time that you'll hear this, to produce a second edition of Airblast 101. It's free. You can download it from Sprayers 101 / Airblast 101. And it's everything you never wanted to know about crop protection in specialty crops using air-assisted spraying. We've used a lot of physics, which, tends to make people's eyes glaze over. So we've kept the tone conversational. We've got lots of illustrations, lots of metaphor, lots of real life examples so that you can find the parts of the book that are relevant to you in your operation. And I do hope you go grab a copy of that. And lastly, Sprayers 101. This is a free, nonpartisan website that I've started with my colleague Tom Wolf, and we're always uploading new articles, new apps, new calculators. It's free. Again, very user-friendly and highly searchable. Just type your question into the search bar and you pick up whatever number of articles or comments or calculators might help you with your question. So that's it for me. I hope you found this valuable, and happy spraying in 2021.